What if every human on Earth suddenly disappeared? How long would it take before the very last artificial light goes out? At first, the answer seems simple. Not long. Most of our lights depend on massive power grids, and those grids depend on us. Without people managing fuel supplies, monitoring demand, and balancing loads, the system would begin collapsing almost immediately. Fossil fuel plants, which generate most of the world's electricity, require constant deliveries of coal, oil, or gas. The moment those supply chains stop, plants begin shutting down. As they drop offline, the remaining power stations absorb the excess load. But power grids are delicate ecosystems. Even with trained operators, cascading failures can happen. Without humans, it wouldn't take long before blackout spreads across continents. Within hours to days, most major grids would fall silent. Nuclear reactors might seem like the exception. After all, a small cube of uranium contains millions of times more energy than a cube of coal. In theory, a reactor could run for a very long time without new fuel. But nuclear plants are built with safety as their highest priority. If something goes wrong, and something always does, the system automatically shuts down. And one of the most likely triggers would be the collapse of the power grid itself. Reactors don't just generate power, they rely on stable grid connections. Without that balance, they would safely power down. The fuel would remain, but the light would disappear. Still, not all light is tied to massive grids. Remote islands and isolated communities often rely on diesel generators. These would keep running until their fuel tanks run dry, maybe days, maybe months. Geothermal plants could continue longer. Some are designed to operate for months between maintenance cycles. But without humans to replace oils, lubricate gears, and manage corrosion, even these systems would eventually grind to a halt. Metal wears down, parts seize, nature reclaims. Wind turbines would likely outlast them. They're built to endure harsh environments with minimal servicing. Some older turbines have run for over a decade without maintenance. Modern ones are rated for several years, possibly longer. Somewhere, one turbine might continue spinning for decades, perhaps with a tiny status LED glowing quietly inside. But eventually, gearboxes would fail. Bearings would corrode. The wind would keep blowing, but the lights would stop. Hydroelectric dams, like the massive generators inside Hoover Dam, could continue producing electricity for years on autopilot. Water would keep flowing. Turbines would keep spinning. But if the grid is down, the electricity has nowhere to go. Over time, mechanical failures and clogged systems would take their toll. Even these giants would fall dark. Battery-powered lights wouldn't last much longer. Even unused batteries slowly discharge over time. Some might glow for a decade or two. A few specialized cells might last longer. But eventually, chemistry wins. Every stored charge fades. Solar power offers a more hopeful candidate. Across the world, remote weather stations, emergency call boxes, and isolated research sites run entirely on sunlight. Solar panels are remarkably durable. In dry climates with occasional rain to wash away dust, they could function for decades, possibly even a century. As long as their circuits resist corrosion and their panels stay clean, small LEDs in forgotten corners of the world might blink on every night, long after humanity is gone. But even solar panels are not the final answer. Because there is another light source, one that doesn't rely on fuel deliveries, wind, water, or sunshine. Deep inside storage facilities, shielded by concrete and steel, sits spent nuclear fuel. Radioactivity itself is usually invisible, but when high-energy particles pass through materials like water or glass, they produce a faint blue glow known as Cherenkov radiation, a kind of optical sonic boom. It's the same eerie blue seen in nuclear reactor cores. Some radioactive waste is fused into solid glass blocks for storage. In complete darkness, these blocks glow blue. One of the isotopes commonly found in such waste, cesium-137, has a half-life of about 30 years. That means even after 2 centuries, it would still retain a small fraction of its original intensity. The brightness would fade over time, but the color would remain that unmistakable electric blue. And so, centuries after cities crumble, after skyscrapers fall and forests reclaim highways, after the last solar panel corrodes and the final turbine seizes, somewhere, in a sealed vault beneath layers of concrete, a faint blue glow would still be shining. Not from life, not from civilization, but from the most dangerous thing we ever created. Long after we're gone, our waste will still be glowing in the dark.